Okay, so yesterday on the first day of volume, we were looking at this this base, and we said, okay, there's this 3D figure that's jumping out at you, and it's made of all these little squares or all these semicircles or equilateral triangles. And so if we can find the area of one of them or of the general cross section, and we integrate, add up all of the slices, it'll make that 3D figure. Okay, before we do rectangle, I want to go ahead and show you what these look like on like 3D pictures of them. Okay, so, well, I don't know why that's quite like that. Well, that doesn't help. Oh, thank you. Okay, here we go. Oh. Sorry. Apparently, I'm going to open up a PowerPoint here. Okay, so let me move this back to squares, and let me I get to move this around, and so here we have a circle, and this is the base. What we're doing is X, Y-axis, and Z-axis is coming right out at us. This base is a circle. The difference between this and what we had on our paper is that these cross sections or slices are perpendicular to the X-axis. Whereas on our paper, they were horizontal, okay? That's the only difference. And so all of these slices are squares. You can't really see that when you're looking at your paper or when you're looking at this picture until I turn it, and you can see here there's all these squares. Okay, so here's a little square, bigger square. Okay, so they're all stacked up next to each other. And truly, when you integrate, there's infinitely many squares. The tiniest little square that you can't even see, all the way to the biggest possible square that has a base of, in this case, 10. On this one, it would be a base of 2 because the circle has a radius of 1. And then it goes, if you go around the side, the squares get smaller and smaller again, and they're all stacked together. Okay? And so if I move this back to where we had it, finally getting the hang of this. Okay, then I'm going to move it to equilateral triangles. Again, from the top, it doesn't really look much different. It still looks like a circle. It still looks like vertical slices. And again, on our paper, we had horizontal slices. But if I turn this, we can see that the stacks, the slices, are all of a different shape. So from the side, it does look different. But from the top, it doesn't look any different. And that's the hard part about the paper. Okay? And let me show you semicircle. So again, looking at it from the top, still a circle, still vertical slices. It's not until you move it where you can get some perspective on it that you can see that all these slices are semicircles. And then this shape makes a shape we do know about, which is half a sphere, a semi or hemisphere. Okay, and that's why with the radius we had to do half a slice. Is this making sense? Can you see it better now in your head? Because the base isn't always going to be a circle. We can change the base shape. So like here, we would have a square base. So if I move this, it looks like a square, but with semicircles, slices, and this makes a shape, you know, it looks like kind of like a bridge or something. Half a cylinder almost. And then there's other things you can do here, okay? Let me go back to circle base and rectangles, because this is the one we're going to do now. Now, one thing about rectangles is that either I have got to tell you that the height is a set height, okay? In which case it would go all the way up, or I've got to give you a proportion so that the height and the base stay the same proportion. So with rectangles, I always have to give you some information. So like with this rectangle down here, let's go ahead and pick up here on our notes. I'm going to go ahead and give you that the height of this rectangle is 3. So I either have to give you the height or I have to tell you the height is 3 times the base or something like that. Okay, so just recall from yesterday, the volume is going to be the integral, bottom to top, because we have horizontal slices on this example. And then the area of a rectangle would be the base, which is the 2 root 25 minus y squared times 3 dy. Okay, and if you wanted to move the 6 out to the front, you definitely could do that. So go ahead and type this in your calculator. Let's see what we get. We're not going to do a lot of calculator work today, but just a little, just to practice it a little bit each day. When you got it, shout it out. Don't shout it out. I just want everybody to try it. There's a lot of little things that can go wrong in your calculator. And if the first time you're doing this is on the quiz next Friday, you're probably going to get a parenthesis error or two. And I want you to be able to identify those and pick them out. That is right. You should get 75 pi. Too many arguments means parentheses. Or you messed up where you put comma x. Or comma y in this case.
You do with respect to x or y and in the bounds?
Yes. So it'd be comma y, comma -5, comma 5. Good. Good job. Okay, any questions on this? Because what we're about to do is just a whole other problem set, but I'm going to go a little bit faster than I did yesterday. Second day. Please ask questions if you have them. 450 pi. Did you move the 6 out like how I did?
On the outside, yes.
Okay. And you did the square root around this and everything?
You know what? I did times 3 because I didn't look down. That's why.
Okay.
Actually, I did the 3 and 6. So.
Oh, that would do it. That would multiply it. Okay. Are we okay to move on? All right, let's go to the next page then. So on this page, we're looking at this. It says we have find the volume of the solid whose base is bounded by, they give us 2 equations. So it's not a circle this time. It's going to be some other shape. And then they give us some more information. Let's just focus on what this shape is. So y equals x, that's pretty easy to draw. It's just the parent function. Y equals 2x squared minus 2x. What shape is that going to make? Parabola. How do you graph a parabola? Plug in x values. Plug in 0, you get 0. Plug in 1, what do you get? You get 0 again. And in fact, these are the 2 roots. For a parabola, could you have more than 2 roots? For a parabola?
No.
No. So, and then this is facing up. So I actually already know what this shape looks like. I don't really know exactly how skinny it should be. I don't know how far down it should go. But this right here is going to give me the general shape of my region. So this, instead of having a circular base, this is the base. So if we were looking at this 3D figure, we're going to, do the volume of in just a second. Looking down from above the aerial view, this would be the base. Okay. So it says the indicated cross sections taken perpendicular to the x-axis. So the x-axis is right here. Perpendicular then would be this way. So we need to figure out, okay, well then, how long is the slice? Now, I could figure it out right here, but remember the slice is moving all the way from the left and right. So this one's different than the one we did a second ago, or a minute ago and yesterday, because we did horizontal slices yesterday. Today, this is a vertical slice. So this is going to be with respect to x, which is good because this is actually the more, I think, the easier case with respect to x. But let's go ahead and figure out, well, how long is this slice in general? It could be as small as 0. It looks like it could go up to like a little bit more bigger than 1. But in general, the slice is going to be top minus bottom. Okay? Just like how we did before. So the top one, in terms of x, is x minus the bottom, 2x squared minus 2x. I'm going to put that in parentheses. And then I'm going to clean it up. 2x squared, and then the minus negative 2x becomes plus 2x, so plus 3x. This is how long the slice is for any given x value. You always have to figure out what's the slice, because this is going to be the base of all these shapes right here. All right, we probably should go ahead and find out where these two things are intersecting. I know that I'm eventually going to need that. So how could we do that? It's not obvious. You could graph it and find the intersection. How could you find this out algebraically? Set them equal to each other. X equal to 2x squared minus 2x, and you could even solve that in your calculator on the home screen. Solve, type this in, comma x. So go ahead and find that out. You can do it in the home screen. You could do this by hand. You could do this factoring, work out a formula, whatever you got, but I want you to find the coordinates at this point. Make sure your answer is reasonable. I know that the number should be between 1 and 2 on both the x and the y. Okay. What'd you get? Okay, so x equals 0 is this one over here. That was more obvious. And 3 over 2, I'm going to go ahead and write as 1.5. Although you could leave it as 3 over 2. It doesn't really matter to me. And then the y value is also 1.5, and I know that because it lies on the line y equals x. So if the x value is 1.5, the y value has to also be 1.5. But that may or may not be important. Okay, so square. Now remember, the area of a square is side squared. So the volume of this shape, okay, is going to be all, we're going to basically add up all the areas of the squares, and these squares are popping out from this blue line. Okay, so the squares are going to be all the way from the left to the right. So what are my bounds? 0 to 1.5. You got to go all the way to that intersection. And then, you know, if we were just doing area of the region, I would have done top minus bottom. But I need to use this formula. So I need to use my slice. And there should be a negative there. I missed that. Did y'all catch that? I left off the negative. So negative 2x squared plus 3x squared dx. Now, I don't, you can plug this in your calculator if you want, but I'm going to go ahead and move on because I want to really just be able to set all these up in a row so we can see the difference. So with semicircle, the area is 1/2 pi r squared. So the volume, again, is going to be 0 to 1.5, 1/2 pi. Now, what's r? Is it the slice? If there's a little semicircle that's peeking up in it's peeking out right here where the base of the semicircle, that's not the radius. What is that? And as far as the circle goes, it's the diameter. So if I know how long that is, I've got to divide by 2. And this is going to happen every single time. So it seems like it's a lot, but then we start to see it happens over and over again. And again, I'm not going to multiply that out, simplify it, or even find the answer. We're going to go ahead and move on to equilateral triangles. Do y'all remember what the area of an equilateral triangle is? Square root of 3 over 4 side squared. So then the volume, again, we would integrate 0 to 1.5 square root of 3 over 4 slice side squared. If we already knew the answer to 5, by the way, could we easily get the answer to 7 without having to integrate?
Yes.
Yeah. What would we do? Multiply by root 3 over 4. That's the only difference here. Okay, so again for rectangle, I am going to have to give you something. And so area here is base times height, and I'm going to go ahead and tell you that the height is 5. So go ahead and see if you can set up your volume equation and check with your neighbor. Don't tell her yet. Let's do it on her own first. How are we doing? Got it? Did any of you accidentally square this? Did you get used to squaring it? For a rectangle, we don't need to square that. Okay. And obviously, if you were solving this, you could move the 5 out to the front and all that. Okay? All right, let's move on to this next one. So this is kind of strange shape, but they also give us the graph, and they tell us the intersection point. Okay, let's go ahead and label everything. Up here, we have y equals 6, the horizontal line. And if I read this, it says the curved part is y equals 2 root x. So it's a square root function with a 2, which caused a stretch or compression, depending on which way you look at it. And then the y-axis. What equation of a line could I give to this line right here? X equals 0. I'm going to go ahead and label that. That might come in handy here in a minute. And to do part A, area of R, this is not volume, this is just area. So this is like what our homework the last 2 nights have been over. Okay, so I want you to try to do this one on your own and actually find the answer, calculate it, and everything. Okay, so we already said this is going to be with respect to x. So what were your bounds? This is, if you got the wrong answer, it's probably for this reason. 0 to, look, this, if we're with respect to x, we've got to go left to right. So you need to use 9. So 0 to 9, and then top minus bottom. 6 minus 2 root x dx. Okay, so let's challenge ourselves. If we wanted to do this with respect to y, I would need to solve this equation for x equals. So I would divide by 2, and then I would square it, which is y to the 4th over 4. Or, no, just y squared. Who knows? It's Friday. Okay, y squared over 4. All right. So if I was doing this, then I would do 0 to 6 because I would do bottom to top, just with respect to y, and then I would do right minus left. So y squared over 4, but on this side I could just say minus 0, and then dy. And I don't really need minus 0. So if we were doing this by hand, with respect to y, would actually be easier to integrate. Okay, but we're not going to do this by hand. So what's the answer you guys got? 18. Good. Did you figure it out? Okay. And that's really easy to happen. All right, so looking at the next part, it says the region R is now the base of a solid. All right, so this is the new stuff. This is the volume stuff. And then it says the cross-section of the solid taken, and we need to pay attention to this, perpendicular to the y-axis. So if I go up here and I draw this, actually let me choose a different color. The y-axis perpendicular would be right here. So when we do this volume, they're telling us which to do with respect to. This is a horizontal slice, so with respect to x or y. It's y. And I know this, I keep asking you guys this because you got to get this, but it just takes some like sorting them out in your head, okay? So we're going to do this with respect to y. So my volume, okay, here's another way I know. If I'm going to put a slice here, then all the slices are going to do this way, right? If I'm counting up all the slices and adding up all their areas, I have to go bottom to top. So what are my bounds? 0 to 9 or 0 to 6? The y value. And look, they kind of gave us a hint there with that piece of information as well. And so it's a rectangle. All right, this is another piece we got to get. So area equals base times height. And this time, don't just say height is 3 and say, oh, height's 3. Look what else it says. 3 times the length of the base. Okay, so I need to figure out my slice. And then we'll finish this problem. So my slice, is it going to be bottom minus top or right minus left? If we look at this, it goes from, left to right. So I'm going to do y squared over 4 minus 0. And again, I don't really need the minus 0. So this is the slice. This is how long any given slice is. All right, so that's the base. The base here is going to be y squared over 4. What is the height going to be? Yeah, 3 times this. Because it says 3 times the length of the base. Then it says write but do not evaluate an integral expression. And so we just need to multiply these. Y squared over 4 times 3x squared over 4 dy. This is how the AP Calculus test might put this on the non-calculator portion of the test. You don't need a calculator to do any of this. You could have even figured this out. This one would have been easier without a calculator. This is a little bit harder to do, but they're not asking you to actually solve it. So either you're going to get a calculator or they're not going to ask you to do all the numbers. Okay? All right.